Hello, and welcome to the webinar launch between Willbros Group and Esri. Thank you in advance for taking the time today to learn more about this groundbreaking technology. The purpose of today's webinar is to showcase and demonstrate the ArcGIS technology that will transform the pipeline project lifecycle. The webinar presenters today are Kent Strasser, who is representing Willbros Group as our Senior GIS and Innovation Center lead, and starting the presentation is Peter Curtis, representing Esri as their partner manager. Thank you, Peter.
Let me introduce myself again. Peter Curtis. I am a partner manager for Esri. I focus on the energy market. Esri provides a core level GIS product, and we depend on companies like Willbros to bring their expertise in the pipeline and utility markets for working with partners. I'm also joined by David Jacob. David Jacob is a solution engineer with Esri and may help with some of our technical questions. So, Esri, we are the world leader in GIS software. We have been in business for over 40 years. Our headquarters are in California, and we have regional offices throughout the United States. For worldwide markets, we have 80 distributors across the globe. Our sales team is focused on 5 major markets, but 2 of those markets are energy and utilities, and we work with a number of pipeline operators throughout the United States and the world. ArcGIS is the core group of products that we offer, but we now call ArcGIS a platform. It provides the core technology that a company such as Willbros can leverage. If we start at the bottom of the slide, you can have your own server technology behind your firewall for your proprietary information. That server can be connected to online content that Esri provides. And then through portal technology, we can distribute your web information out to either desktop clients, to web clients, or even to mobile devices such as smartphones and tablets. So again, talking about ArcGIS as a platform, Esri provides GIS products for desktop computing, for web map deployments, for mobile solutions, and for cloud-based technology. So Willbros is going to demonstrate today all of those capabilities, and Kent, look forward to your presentation.
Before we start, I just want to thank Peter and David for participating in this webinar. Their support means a lot to us here at Willbros. We have been working with Esri now for about 3 going on 4 years with our partnership, and we are very proud of our history that we have with Esri. Willbros was founded in 1908 as a Williams Brother company, and since then we have grown to over 10,000 employees worldwide. We are a full service provider in engineering, procurement, construction, operations, and maintenance for oil, gas, and utility industries. Here at Willbros, we make every effort to provide a good job on time, done right. Today's webinar is based on the pipeline project lifecycle and how we utilize the Esri technology in doing so. There are 3 phases of the pipeline project lifecycle that we're going to go through. The last phase of construction, we will hit on that phase later on. Today's phases will be phases 1 and 2. Preliminary engineering for phase 1. Phase 2 will be right-of-way, permitting, and detailed design. Started first with phase 1 preliminary engineering. This is how we start our pipeline projects, utilizing Willbros and Esri leading the way. And we're going to start with the Esri landscapes. What this is a data mining solution provided by Esri. We all know that data mining is difficult sometimes. Pipeline projects, you need data right now. Esri has provided the perfect solution to getting pipeline projects started, as well as to continually support a pipeline project. Esri Landscapes allows the project to have an abundance of data at the project's fingertips, all within the United States. Landscapes provides data critical for permitting, right-of-way, engineering risk, and environmental concerns, just to name a few. ArcGIS users can view and extract data directly from Esri's ArcGIS server for almost instant use. The extract tool that Esri provides clips the data pertaining to the ArcGIS user study area and then imports the clip data into a file geodatabase. This file geodatabase is then zipped up and placed within a specified folder on the user's laptop or desktop computer. These are some of the layers that Esri is providing to us. These are layers that are critical for pipeline routing, everything from permitting to engineering design factors to right-of-way. This allows us to get a huge start on projects and make a jump forward. We can collect all of this data and then start our initial analysis on the project. The landscape tools dramatically cut down on our data mining hours, which in return really helps us out and keeps us from being frustrated from searching so many sources out on the internet or calling local agencies to get this information. As you can see here, landscape layers that Esri provides, there's more than what I just showed you on the left-hand side. They also have unprotected areas, transmission lines, surface water area, soil water table depth, just to name a few. And here we'll jump into our demo of utilizing these layers. So here we have an ArcGIS desktop session open, and we've gone to our GIS servers and we've added the ESRI landscape layers. And here's all of our layers that are defined, as well as our extract landscape source data tool. And as we scroll through here, we can see everything that we showed you in the list prior. This has, like I said, a lot of information that's critical for pipeline routing. So we'll go ahead and we'll add some layers into our study area for our pipeline project. We'll add aquifers, we'll add hazardous waste sites, and we'll add some conservation easements. So here you can see the layers directly in our ArcMap session. We'll go ahead and we'll zoom in on our project study area. And you can see our pipeline route with the information we just pulled in from Esri layers, or landscapes. And over on the left, you can see the symbology. Everything is predetermined for you, so you don't have to do any type of symbolization or any type of joins to the data to get the information that you need. We'll go ahead now, and we'll zoom in here. And you can see some of the conservation easements that are within our study area. Now we'll go ahead and use the extract landscape source data tool. And we'll choose our landscape layer that's within our study area. So from here we can source our layer. And you can see the abundance of information that Esri provides us. And we'll extract NWI wetlands. Now the tool is running. And once the tool is run, then it's placed on a specified location on our computer, and we can extract that information from file database and instantly start utilizing. The preliminary pipeline routing optimization tool. This is a tool that was developed in-house here at Willbros that utilizes the ArcGIS platform. PPRO utilizes GIS data to provide a preliminary route as well as a way to defend the generated route with a risk assessment, cost service, and crossing tables. This provides visual and analytical proof of routing design all at the project's fingertips. The Esri landscapes works perfectly for this tool because we can extract all that information and we can put it in this tool to generate our pipeline route for preliminary use. Getting the pipeline project off on the right foot, it's critical. Utilizing the PPRO tool for preliminary routing saves time and potential headaches from regular desktop routing. What we can do is we can gather as many data sets as we possibly need for a pipeline project, and we can define those data sets, set a weighting scale to that data between 1 and 1,000, and the Esri geoprocessing then takes care of the design process for creating the route. This tool is critical for us to use as pipeline projects get bigger and bigger and routing gets harder and harder. This allows us to generate a pipeline route more accurately and quickly, saving a lot of time and money. We'll jump into a demo here. This is our project study area, and if you see here are the gray lines, we have to parallel these gray lines and start from the start point and end at the stop point. So here, this is our tool. We have all of our information already specified. We have our start point, our stop point, as well as our study area. We've defined our slope. We're going to define fault lines, land ownership, and structures for this demo. We've got our output set, and we've specified our raster cell size for route selection at 50 to help move this demo along. And we'll input the route name. Normally, we set the resolution down to probably 30 feet to 10 feet. But for this scenario, we need to move as quickly as we can, so we set it to 50. So now the tool's running. It's analyzing all the data that was in that study area that we specified. And now it's calculating our route. So this is a 70-mile 2D distance linear route. If we were to go from start to stop, straight across, what we're going to have now is a tool that meets, or a route that meets the criteria within our tool. And this route will be the starting point for us to get going with our project. This should take about 3 minutes to run. We've been utilizing this tool on several projects now, ranging from 25 miles clear up to 400 miles. We've also been doing route comparisons with multiple routes that are already provided to us within this tool. We can throw in optimized routing corridors and run our tool against all the data that we have in a project area and create a preliminary pipeline route for the project team to review quickly. Once we get done with this route, we can then throw it into our crossing report tool that I'll show you here in a little bit to generate crossing reports that define what's around our pipeline route and not just what's crossing our pipeline route. So it defines both features within that corridor, and whether they're offline or online. So we'll let the tool run here. And as I said, we define slope, fault lines, land ownership, and structures for this run. We can throw as many data sets as we need to into this tool. We've run up to 85 data sets within this tool within a 400-mile route. So putting as much information in the tool as you can is possible, as long as you have the processing power, which we do here at Willbros as we utilize cloud computing. So we'll let this tool run here. What this tool does is it helps us move the project along quicker. As soon as you start your kickoff meeting, then you can immediately go to routing. You can get all the information that you need. You're not pulling out maps or looking at a website to generate your route. So here the route has been generated, 3 minutes and 21 seconds. We'll add our route in to our study area. And here's our route. So we'll zoom in here based on our co-location line or our line we had to parallel. Now we'll go in and we'll add our risk assessment cost surface, and we'll symbolize it accordingly, green being a low risk and red being a high risk. And here you can see why the route was generated the way it was. So you can see we've paralleled an existing line, and we've avoided certain features that we've inputted into the tool based on our weighting criteria. And we've generated a least cost path route in terms of distance and impacts, all directly from the GIS data. And here you can see our slope. So you can see where we've stayed on the green and then minimize the slope factors. So we'll move on to our crossing report tool. Crossing reports are critical for a project. When you're doing a preliminary pipeline route, you need to know what is around the pipeline route, not just what's crossing the pipeline. We need to know this for permitting and cost estimating. This is critical for pipeline. This crossing report tool provides crossing tables identifying features that cross the pipeline route as well as features that are offline within a specified corridor. The ArcGIS user can go in and specify the corridor around the pipeline. It could be a 300-foot environmental study area, a 500-foot construction corridor, or even just a half-mile or 2 or 3 mile buffer around the pipeline. The user can specify the information, put all of the features that were used in, say, for instance, the routing tool into the crossing report tool and generate these crossing reports. So what the crossing report provides is mileposting or stationing, crossing links, acreage impacts, distance and an offline feature is from the center line, county, state, latitude, and longitude, just to name a few. So we'll show you an example of the crossing table. So this is our slope crossing. This shows our start mileposts and mileposts, as well as our percent slope. We'll move over to roads. Shows our road crossing. Shows how far it is off the pipeline if it doesn't cross it. Shows our railroad crossings. And this shows our water well buffers, as well as how far the well buffer is inside the 300-foot pipeline corridor. This shows our structure crossings. It is similar to the well crossings in which it shows how far the buffer is inside the 300-foot corridor. And then we get into land ownership crossing. So we can show our start and mileposts, as well if the landowner crosses the pipeline or not, how far they are off the pipeline. And we can also provide acreage for how many acres are impacted. And here's our NHD water body crossings for preliminary analysis for permitting. As you can see, we can see how many acres are impacted within that corridor. Same as with the wetlands. We can determine crossing lengths, acreage, county, lat, long, all the information we need to get going. The next topic is ESRI Maps for Microsoft Office. This is a very powerful tool that has really enhanced our projects. Have you ever received a crossing table and not have a map to cross-reference the table? This eliminates maps directly in your hand. This allows you to have a map directly in Microsoft Excel tied to that crossing report. In certain pipeline routing scenarios, features often overlap, making it difficult to distinguish between features. Even when features do not overlap, it is usually difficult or impossible to visually extract meaningful information when hundreds or thousands of features are shown all at once. Even though you have a map, we can now go in with our features in the crossing table and identify based on heat maps and clustering within the ESRI Maps for Office. We can identify areas that have a high concentration of forested wetlands, areas of critical environmental concern, and also known problematic landowners, just to name a few. So here's our crossing tables, and we've already inserted our map from ESRI Maps directly into Microsoft Excel. This is an app that you can download. And you can go in and you can change everything up, your visibility range, your layer details, you can do selects, you can copy the image from the map, create a slide, you can share your map to the project team. And so for now, we've already added in our feature-based service that we set up on ArcGIS Online, and we provided the pipeline route and wetlands, and then we've added our Excel layers in that are referenced from the crossing report for NWI wetlands. So from here you can see our crossing information. We'll go ahead and minimize that. And the little pinpoints are actual crossing locations from your crossing report that directly referenced into the map. So all your information in the report is in the map as well. So we'll zoom back into our project study area. And we'll go ahead and zoom in. And we'll right-click on our row, and we'll go to Go To Location, and it will instantly zoom to this wetland crossing. So now you have a powerful map in your hands as well as the actual data itself. So everything is more visual for the project team. So you can go in and through Esri's reporting, you can create custom reports. If you need to know certain things within a radius, you can do that. And then you can also go in and you can add enhancements to your data. So you can do the hotspots, you can do the heat maps, you can add information from Esri to your data. And we'll scroll down the line here. And we can go in and we can change our base maps. Esri provides numerous base maps for us to utilize. So from here we've got topography base map. And we'll go in and we'll add our imagery back in. And we'll add one more map just to kind of show you how fast it is, how fast everything renders within the map in terms of what your data is tied to in the map. So we'll move on to our Willbros GIS tools. These are a couple of tools that we created in-house utilizing the Esri geoprocessing as well as some of our custom scripting. The first tool was our property sketch tool. This is a customized property sketch generation tool driven by Esri's ArcGIS desktop. What this tool does is allows us to generate hundreds of property sketches for a pipeline route based on a property boundary, and allows us to provide all that information, provide these maps, provide critical calculations directly to our right-of-way agents to get to talk to our landowners. We can take our route that we just generated and review it, and then we can input it into our property sketch tool and generate hundreds of sketches. Say, for instance, you have a route that has 500 property owners. We can generate those sketches and have those out the door in 84 minutes if we have the right data in place. This cuts down on man hours and time and frustration from dealing with numerous property sketches on a project. So as you can see here, here's an example of one of our sketches. And this is driven by our new construction APDM geodatabase that we're developing here. All the calculated information, pipeline route, workspace is directly derived from a database. We're not going into our map and clicking on a number and inputting a number. Everything that you see in this document here is database driven. This is part of our profile tools. This creates a pipeline profile based on elevation points that could be from survey, a surface model, or any other type of information that you've got, such as an ILI run with elevation points already in it. We can then take that information and create a profile, and when we create the profile, it provides an Esri shapefile of the profile, a spatially referenced 3D measured route, and a Microsoft Excel table with reference points, elevations, 2D measures, and 3D measures. So you have all the information that you need in your hand ready to go to start creating maps and to start doing hydraulic analysis as well for preliminary use for engineering design. So this is a part of our profile tool. This is, like I said earlier, this is all database driven. We do not utilize shape files for stuff like this. As you can see here, we have all our information on the left-hand side. Pipeline ground profile, grid line reference, measure reference, grid lines, and all of our features as well. So we can scroll around our profile, and we can check our profile out and look for any type of busted elevation point that's provided to us. So it makes for a more efficient way to check your elevation information. So we can zoom in now to a water body crossing that's in our database that's referenced based on 3D and 2D measure. As you can see below the 2D measure. And then we'll zoom in on our water body feature. You can see the mileposting, the elevation, and the 2D and 3D measure, and you can see the difference in the measure. So it automatically provides that information to you. And we can measure and reference it. It's just like a map, but more profile design driven for engineering analysis. Okay, we'll jump into phase 2, right-of-way permitting and detailed design, advancing pipeline projects with Willbros and Esri. ArcGIS Online, this is a really cool tool that Esri is providing to everyone. This is something that should be taken in hand for every project. We thoroughly enjoy using it. It provides full project visualization. It provides project data distribution and project reporting tools. So the full project visualization, it provides online web mapping service, and what more do you need from that? And the ArcGIS Online user can upload data, map it, and then share it to the project, saving time and enhancing communication. Project data distribution, distributing data to the project team is simplified greatly. ArcGIS Online allows for tracking or constraint verification and easy data tagging, just to name a few. Project reporting tools, getting your point across with reporting tools from ArcGIS Online allows for maps to be interactive with the project reporting. What is a good detailed report without a map to verify the report? ArcGIS Online provides all that information at the tip of the project's fingertips. And then we'll get into ArcGIS Online. And from here, we're going to go ahead and we're going to add some data and distribute it to the project team. So we've gone ahead and created our project folder, and we're going to add an item. And what we're going to add is a file geodatabase from our computer, but we'll show you what you can also add from the web and from an application. So we'll go in and specify what our data is. It's a file geodatabase, and we'll tag our data. So this is instantly saved once we add item. Now it's uploading the item to ArcGIS Online within our project folder. So it's been uploaded. Now we can go in and reference the information. We can provide a description. We can provide access and use constraints. Properties, and then we can also share it. We can share it to the people within the project group. So these will be the only people right now who can see this data. And we can also go back in and, if we need to, update and share it to maybe people within Willbros. And now it's shared directly within people within Willbros. So here you see a summary, description, all the information you need to input, as well as properties and some of the information we put in for tags. We can also move this data, and we can also change the owner of the data. This is a part of the My Map information from Esri. What this is we can input our mapping data directly into the ArcGIS Online. And so as you see here, we already have our pipeline route, and it provides all the tools that we need for our project. So we can go in and we can specify what our background needs to be. Do we want streets? We can add streets. And you can see it's really fast. So we'll scroll down our pipeline route, and you can see the street names. And we'll go back in and we'll add our imagery back in with our labels. So here's one of the coolest things I think about it. So from here we can add certain layers in. We can add them from the web, we can add them from file, we can add map notes. But now we're just going to browse the ESRI or Esri map layers. So we can go in and add specific information from the Esri landscape that I showed you earlier. So we can grab imagery, we can grab people, we can grab earth categories, life categories. As you can see, as I scroll scroll down, you can see all the information. So for now, we'll grab soils. And we'll add this to our map as a base map. So now you can see where our pipeline route is in correlation with our soils corrosion factors for the Surgo data. Now this is all the soils that are corrosive to steel. So this is good for understanding what type of coating we need in certain areas, if we need to apply it, if not. And we can instantly see where we need to do that. And we can also extract this information, put it on our desktop, and run our analysis. So here I just save the map, and now I'm going to share it with members of the Northern Region Energy Project. And now it's been shared. So everyone will be able to see this map on the project. So from here, reporting becomes a huge deal on projects. You have to be very thorough with your reporting, as you know, but you also want to be able to show your reporting off, show it within a map, because everybody asks, where's your map? You have a report, where's your map? So from here, you can create what Esri has set up as story maps. You can take these templates and you can create reporting templates to take to a meeting, to take in front of a client, to show how the progress of the project is going. So we'll go ahead and we'll show this is one of Esri's mapping of the shale gas boom. This is good for preliminary use for understanding your project, for understanding where to start, maybe if you need to start around a major shale area. So you see here with the legend, they have a legend area in place that you can modify. If you zoom in, everything is based on the category on the left-hand side. So now we moved into shale gas production by state, and everything. You can go in and do custom symbolization and really define your map with what you need to present. So you can see this, the legend can dynamically change with the data or within the information in the map. And you can zoom in and you can see major data for understanding your project. And you won't need a paper map, or you won't need a separate map. You can just do your report and mapping all in one template. Centerline and project data management. Here at Willbros, we are database and data model driven. We have a lot of people in the industry, or a lot of people in our office that work within the industry for data modeling. We utilize a geodatabase for all of our GIS projects as much as we possibly can. We are critical in that because we feel that it is the most effective way to manage GIS data, and Esri provides that within their file geodatabase and also in their enterprise geodatabase. The SDE databases allow for efficient ways to manage and track your data, and also the geodatabase allows you to manage your metadata and defend your data better. Typical places store their data in shapefiles, and they'll put them in folders, and it's hard to reference where the metadata is or where it was from. From here, we can store our information and then tie the metadata to our actual data itself and manage it all in one source. So how can Willbros help? So phase one, we went over preliminary engineering. We can help your project by GIS-enabled routing with the PPRO tool, substantially cutting down on hours and allowing the project to flow more smoothly in terms of routing. We can go into right-of-way property drawings and generate property sketches quickly and efficiently, saving time and money. We can do profile generation with our tools. We can quickly validate our data and also make any modifications as need be with the data within that profile. So we can go into phase two. Phase two are right-of-way acquisition, environmental permitting, and detailed design phase. We can push all of our data directly into our new construction data model, and we can manage our center line within that model. Management of change, the MOC process within the center line, is very critical on projects, so we can do that within our geodatabase, and we can manage it more efficiently and quickly, and we can also do activities within that reporting, and we can understand the process or the life cycle of our center line. So in return, this reduces high costs for environmental, civil, and right-of-way acquisition teams for rework. So earlier I said we would touch more on phase three for construction. There will be more to come with another webinar. We'll be jumping into as-built survey data, quality control systems, construction management reporting, electronic field inspection data capture, line pipe material tracking, and other things such as welder performance tracking and automated alignment sheet generation. Thanks for joining us here today. I really appreciate everybody's time. If you have any questions, please go ahead and start right now. I'll be really glad to answer any questions. One question is, how long does it take you to set up your PPRO routing tool for a project that is 200 miles? That really depends on your study area. So say, for instance, if you're in an environmentally sensitive area and you have a lot of data sets, or you're in an area that has a lot of factors for routing that could hinder the route, then it depends on how many data sets we're obviously going to use. Say, for instance, we have a pipeline route with 200 miles that we're going through 13 to 14 different counties, maybe 2 different states. It could take us 8 hours, 10 hours of prep time, and then by the time we run the route and get you the crossing tables, we could be around 20 to 30 hours. But with that, you're getting a more enhanced route, accurately defined tables that show how your route is going to be in terms of what's around it for its surrounding environment, and allows you to start your permitting process. This can significantly reduce time and costs and deliverables for a project. Say, for instance, the crossing report tool. Old methods would be you would sit down with some of the geoprocessing tools and you would just do your intersects based on the data, and you would kind of go in and manually manipulate the information. What would take maybe an 8-hour day to do with our crossing report tool, with prior crossing report methods, we can do with our crossing report tool in a matter of minutes. We can throw as many data sets as we need into the crossing report tool, add our center line in, and then effectively let the tool run, and then it outputs the information that we need.
So Kent, this is David Jacob. I'd like to answer some of the questions that relate to Esri and ArcGIS.
Okay, great.
So one of the questions that came in was about the Esri Maps for Office plugin. So it is a component of your ArcGIS online subscription. So it does need to be installed on a machine that an Excel user who wants to visualize that same data that their colleague has created in their Excel spreadsheet. Another question that came in was how secure is the data that's sent to ArcGIS Online? So ArcGIS Online is Esri's cloud-based data sharing platform that Kent just demonstrated, and we use state-of-the-art security practices, sort of defense in depth approach to securing data. The individuals who or clients who publish data to ArcGIS Online retain their intellectual property rights over that data when they publish the data to our cloud. And we have certifications that's been done on our system, and is documentation is available for interested individuals. Privacy certifications like Trustee and Safe Harbor, and also on all the infrastructure that we use, relevant certifications have been applied. And we use HTTPS and other encryption to, when all of the applications publish data, it goes over an encrypted channel, and the sharing of data is restricted based on the user that has access. And as an organization who has an account on ArcGIS Online, the administrator of that account can further restrict permissions on how widely users in that company can share data outside their organization as well. And one other question was, how does one get access to ArcGIS Online? So it's easy as going to www.arcgis.com, and you can, if you don't have an account, you can sign up for a 30-day trial and get a feel for the platform. And you can always talk to your local Esri representative.
Okay, David, I'm going to jump back over to me here. I got a question. What are your system requirements to run your PPro tool? You mentioned cloud computing, but what are the specs of the machine you use to run the tool? I actually ran the tool locally on a laptop of mine. Really all you need is ArcGIS Editor and then Spatial Analyst. We are providing this as an in-house tool and not as a service. We do run it on our Amazon instances for our cloud computing. If we get into a really big project, we need to run multiple routes, maybe 4 or 5 routes, we'll throw it up in our cloud-based computing on Amazon, and we'll run the routes. We can generally run a route, 200 miles with 50 data sets. We can create a route from the tool after the data has been prepped in less than 30 to 40 minutes. Also, we got one more question. The specs on my laptop, I'm utilizing an HP laptop with solid-state drive, an i7 processor. My RAM is 16 gigs of RAM, so it's a very powerful computer. It allows us to really push the tool along, but like I said, we can also put this up in the cloud. Can we touch on saving time for property sketches? Absolutely. Typical property sketch generation would take days. If you had 100 sketches, you would need 3, maybe 4 people to get that turned around in 2 weeks or a week. With the tool, we can turn around very quickly. Like I said earlier, we can generate 500 sketches in 84 minutes if we have the appropriate data to get us started. So we eliminate hours, we eliminate manpower, and we provide that accuracy within our data. We're not having somebody sit down and key the information in. It's all driven by geoprocessing scripting and also stored in our database. Okay, Stephanie, I think that's all the questions we have.
Thank you for taking the time to join us today for the Esri and Willbros Group Partnership webinar. Your presenters today have been Kent Strasser, our Senior GIS Innovation Center Lead for Willbros Group, and Peter Curtis, the Partner Manager for Esri. Please submit any questions or clarifications to integrity at willbros.com, and we will have a representative contact you as soon as possible. Thank you, and have a great day.